Now we will discuss on electron dot structures. Electron dot structures in carbon and its compounds. Okay. Now, so why we have to write electron dot structures? Because we have to know that the sharing of electrons between two atoms. That's why we have to write electron dot structures, and we have to understand what is going on in the electron sharing of between two atoms. So the reactivity is explained. The reactivity is explained as their tendency to attain a completely filled outer shell. So that is to attain noble gas configuration. This is the meaning. Okay, now one by one we will discuss. So this electron structure first we will discuss in carbon. Okay, its atomic number is 6. Okay, now electron distribution in the shells, it is K and L. K it is 2 and L it is 4. So this is the outermost shell. This is the outer shell. These electrons are responsible for the bond formation with the other atoms. Okay, that means what? So carbon want 4 electrons to attain noble gas configuration. Noble gas configuration. That means see, either it has to lose these four electrons, or it has to gain 4 electrons. That we will discuss now. See, suppose it is losing 4 electrons. So suppose it could lose 4 outermost electrons. By losing their electrons, their 4 electrons forming, see here, it is now we are discussing on losing 4 electrons. That means electrons having negative charge. Electrons having negative charge. That means it is losing negative charge. That means it is losing 4 electrons. In case carbon now forming is, it is a cation. That is C4 plus cation. So why you got this 4 plus? I think you understood. Okay. But losing these 4 electrons, that is very difficult because it requires large amount of energy. Energy to remove to remove 4 electrons. And now we will discuss on gaining. Suppose now we will discuss this part. Suppose it is getting 4 electrons from outside. What will happen? That we will discuss. Suppose it could gain 4 electrons. Then now it is getting 4 electrons. It is getting 4 electrons. That means what? So electrons have negative charge. That means it is gaining negative charge. Okay. That means the carbon formed is, it is an anion. Okay. So that means formation of C4 minus anion. Now you think, see, it is having a nucleus. In that protons and neutrons are there. So it is having a atomic number 6. That means it is having one shell, it is having 2 electrons, and other shell it is having 4 electrons. Okay. Now you think it is having outermost shell, it is having 4 electrons, and suppose it is gaining 4 electrons from the neighboring atom. What will happen? It is difficult. Here only protons, only 6 protons are there. That means these 6 protons is not able to handle this extra 4 electrons. That is the problem. So, but it could be difficult for the nucleus. Nucleus with 6 protons to hold on to 10 electrons. See, here 2 and already 4 and one more 4, that all 10 electrons. So it may difficult for proton to handle these 10 electrons. So this is also problem. To overcome this, carbon has having a solution for sharing its valence electrons. electrons with other atoms. With other atoms of carbon or with atoms of other elements. Okay, this problem not just for carbon. This problem, it is not in only carbon. But many other elements form molecules by sharing electrons. Okay. Now we will discuss some electron dot structures. How carbon is sharing electrons with neighboring atoms. That we will discuss now. See, here we will start. See, this is the carbon. Carbon, how it is sharing its electrons with the neighboring atoms. That we will see now. So, example, we will write example methane. So, its molecular formula is CH4 and its structure is this is the structure of methane. Now this we have to show in the way of electron dot structure. See, carbon, first we will write carbon. Carbon, it is having 4 outermost electrons, that we will show it as a cross mark. Hydrogen electron we will show it as a dot. Like this we have to show dot, and also near to that we have to write H. So like this we have to write dots. So that means carbon, you see, carbon, it is having 4 outermost electrons. See, 1, 2, 3, 4. Carbon is having 4 electrons, and now you see 1, 2, 3, 4 plus hydrogen 4 electrons. That means 8 electrons. So that means that methane molecule, that means carbon is reached noble gas configuration. This is the meaning. Now we have seen the carbon. Hydrogen also we have to see. Just you see here, hydrogen is having 1 electron. That means atomic number of hydrogen is 1. That means K shell, it is having only 1 electron. To reach noble gas configuration, hydrogen wants 1 more electron. So it shares its electron with carbon. Just you see here, it is sharing this electron with the hydrogen atom. Just you see here, and you see here. It is sharing its electron with the carbon. See, hydrogen sharing its electron with carbon. See here also, it is sharing with the carbon atom. See, this is the electron dot structure of. This is one example. Now we will see second example. So, electron dot structure of ethane. Ethane we will see. See, ethane, it is having a molecular formula C2H6. Molecular formula. Okay, its structure is C hydrogen. So this structure we have to make it as dot structure. Okay. Now what we have to do? We'll discuss. See, carbon. Now we will discuss carbon, ethane. So it is having 4 electrons in outermost shell and here one. Okay. So it is having 4 outermost electrons, 3 plus 1, 2. Now clear. Okay, now hydrogen we have to show. Hydrogen, this is hydrogen and here it is hydrogen, here it is hydrogen and here it is hydrogen and here it is hydrogen and here it is hydrogen. Now you see this carbon you take 1, 2, 3, 4, 5, 6, 7, 8. Okay. So from here onwards we have to take this is the carbon noble gas configuration 2, 3, 4, 5, 6, 7, 8. Now you take this carbon, same, from here you start. So now you count 1, 2, 3, 4, 5, 6, 7, 8. 8 electrons. Now this carbon also reached noble gas configuration. Okay. Now hydrogen we have to see. See hydrogen, it is also reached noble gas configuration and here also it has reached noble gas configuration and here you see it has reached noble gas configuration and here you see it has reached noble gas configuration and here you see it is reached noble gas configuration and here also you see it has reached noble gas configuration. Okay. Now we will see the dot structure. This is the second. And third we will see electron dot structure. Dot structure in ethene. Ethene. See, ethene is having a formula of. Now we will see the electron dot structure in ethene. Ethene. That means it is C double bond C H H H and H. So this we will make it as an electron dot structure. C 2 electrons and C 2 electrons and here 1 electron here 1 electron, here 1 electron, here 1 electron. So 4 hydrogens we have to show now. Dot H, dot H, dot H, dot H. Now you see that we want 8 electrons per carbon. Now you see 1, 2, 3, 4, 5, 6, 7, 8. Now it has reached noble gas configuration. Now this carbon we will see. Now you count 4, 5, 6, 7, 8. This carbon also reached noble gas configuration. Now we will see hydrogen. This hydrogen, see, it is sharing its electrons with carbon and reached noble gas configuration. And now you see this hydrogen, it is sharing its electron with the carbon and reached noble gas configuration. And here also this hydrogen, it is sharing with electron with carbon and reaching noble gas configuration. And here also you see same hydrogen is sharing its electron with the carbon. Now all are reached noble gas configuration. Okay. Now carbon we have seen. Now hydrogen we will see. How hydrogen is showing dot structure. Okay. See, hydrogen is having atomic number 1. So that means it is having half filled K shell. That means K shell it is having 1 electron. That means to reach noble gas configuration, it requires 1 more electron. Then how it is? This is hydrogen. Hydrogen we are discussing. That means it requires 1 more electrons to reach the noble gas configuration. Hydrogen, just you see, hydrogen it is having 1 electron, and 1 more hydrogen it is having 1 electron. Okay. Now after sharing, the hydrogen becomes hydrogen. So it is reached noble gas configuration. Now you see it is reaching noble gas configuration. So this is called hydrogen molecule. Hydrogen molecule. That means hydrogen is having single bond with another hydrogen. Okay. So single bond between 2 hydrogen atoms. This is single bond. Single bond between 2 hydrogen atoms. This is the electron dot structure formed while forming hydrogen molecule. Okay, these are all very, very important. They may ask in the examination. Now we will see oxygen. Oxygen. So electron, the atomic number of oxygen is 8. So that means the electronic configuration of oxygen is K, L, 2 and 6. So that means oxygen is having 6 outermost electrons. So these electrons, they will share the outermost electrons with the neighboring atom. Now we will see how oxygen molecule is forming. See, oxygen, it is having 6 outermost electrons. So one more oxygen. Now dot structure we will see. Oxygen, 2 electrons, 2 electrons. Okay, now here 2 and here 2 and here 2, here 2. Now you see, now you count 2, 4, 6, 8. Now this oxygen reached the noble gas configuration. This oxygen we will see now. See, 4, 6, 8. This oxygen also reached noble gas configuration. So now it is called as an oxygen molecule. Carbon, oxygen and oxygen. Oxygen to oxygen, it is a double bond. Okay, so that means double bond between 2 oxygen atoms. So oxygen also we have seen. Now nitrogen we will see. Nitrogen we will see. So atomic number of nitrogen is, atomic number of nitrogen is 7. So that means nitrogen electronic configuration is 2, 5. So nitrogen is having 5 outermost electrons. So that means nitrogen three and here 2 electrons. And same nitrogen 3 electrons and 2 electrons. So after sharing these 2 nitrogen with their electrons, nitrogen 1, 2, 3, 1, 2, 3 and 2 electrons here, 2 electrons here. Now you start from here. See, nitrogen 3, 3, 6 plus 2, 8. It has reached noble gas configuration. This nitrogen you see now. So 6 plus 2, 8. It is also reached noble gas configuration. This is the dot structure of nitrogen. So now this is called nitrogen molecule. Nitrogen molecule. That means nitrogen is having triple bond between nitrogen to nitrogen. That means nitrogen to nitrogen, it is a triple bond. Okay. So triple bond. Between nitrogen atom. See, one single bond we have discussed, one double bond we have discussed. See, this is double bond, single bond and triple bond we have discussed. And NH3 also we will see how NH3 is showing the electron dot structure. So nitrogen, just we have discussed, it is having a outermost electrons, it is 5, correct na? So that means nitrogen 3 electrons here and 2 electrons here. Okay, see, this is ammonia, that means NH3. NH3 dot structure, just we will see. See, that means 3 hydrogens are there. 1 dot here, okay, and 1 dot here and 1 dot here. These are all the hydrogen. Now you see nitrogen. Now we count 1, 2, 3, 4, 5, 6, 7, 8. Nitrogen reached the noble gas configuration. Hydrogen we will see. See, this is the hydrogen sharing its electrons with nitrogen. But you see here 2 more electrons left without sharing. That is different chapter that you will study in the higher studies. Okay, so this is the electron dot structure of NH3.